forms of energy. So, we have talked about already that energy is the ability to do work. Now, that comes in lots of different forms, right? Could be the work of motion, could be the work of powering something with electricity, could be the work of creating light, any of the above. The first part of your notes there says list the 5 forms of energy. So, they are light energy, which we've already discussed. Electrical energy, which we also already discussed. The other 3 we're going to talk about today. Now, you do not need to include potential and kinetic, okay? But I do want you to include mechanical, sound, and thermal, okay? This is why. Potential and kinetic combined make mechanical, okay? So these are like sub-parts of mechanical energy, all right? So a lot of people like to remember the 5 forms of energy with the acronym MELT, okay? MELT, okay? The M stands for mechanical, the E is for electrical, L is for light energy, T is for thermal, S is for sound, okay? These are the 5 forms of energy: mechanical, electrical, light, thermal, and sound, okay? We've already gone over electrical, we've already gone over light. Today we're going to mention mechanical and thermal, and then tomorrow we'll finish up with sound, okay? All right. So, first, mechanical. Mechanical energy is the sum of kinetic and potential, okay? That means sum is the math process of adding, correct? So, mechanical is the addition of kinetic and potential energy, okay? Those two combined make mechanical. It's the sum of kinetic and potential energy in an object that is used to do work. One of the key words for remembering what mechanical energy is discussing is the word motion. Think of the M in mechanical as the M in motion, okay? Mechanical energy is the energy of motion. Whenever any action is performed, there is an object supplying the force and an object that receives the action, okay? Let's hang out there for a bit. Talking about the roller coaster, okay? There is an object supplying the force. The force that's moving the roller coaster is the combination of the engine and the wheels and the tracks on the actual like metal track of the roller coaster, right? That's what moves the cart, correct? That's supplying the force. Nod your head if you're like understanding what I'm saying. Okay. What is receiving the action of that? Trinity? The cart. The part that you actually sit in that moves with that action, correct? Okay. So that would be the example of the roller coaster. Now, also, kinetic and potential, a great example is roller coaster, okay? Kinetic is when the energy is actually, when the motion or the work is actually happening. Potential is when that object has stored up and could potentially perform the action in seconds, okay? So, like with the roller coaster. As the roller coaster climbs up the hill, it is moving. It's in the process of action, right? So that's kinetic, all right? It is building the potential to fall down, which means the potential energy is increasing. At the top of the hill, the cart has not a lot of kinetic energy. It's not moving fast. In fact, sometimes it even stops for a second, right? But it has a ton of potential energy. Because in a second, it's going to tip over and fall down to move very quickly. Does that make sense? All right, so the roller coaster falls down. Now, potential energy is decreasing because it's getting lower and lower to the ground. It has less potential to drop, correct? But the motion is getting faster and faster. So now, kinetic is increasing, but potential is decreasing. Does that make sense? So, think about it like this. If this is the amount of energy the object has, okay, of mechanical energy, the whole thing is mechanical, okay, part of that is kinetic, part of it's potential. So, at the top of the hill, the roller coaster has maybe this much potential energy, but only a little bit of kinetic. It's not moving super fast, but the potential for it to do so is very high, right? Okay? As it begins to fall down the hill, this bar, it gets faster and faster and is losing potential. So now it's here. At the bottom of the hill, the potential energy is really small, but there's a lot of motion. So it has a lot of kinetic. Does that make sense? So the energy is being transferred kind of back and forth between kinetic and potential. Does that make sense? Okay. Thinking about the weightlifter guy. All right, let's go back to the object supplying the force and the object receiving the action. What is supplying the force for this buff guy? Connor?
I don't really have the answer, but he kind of looks sad, and on his shirt he has like a little sad.
Yeah. Okay, Connor, come back to me. What is supplying the force?
His own strength.
His arm strength, his muscles. Good. What is receiving the action? Hannah? His body is the one receiving the action. What's being moved? His arms, yes. So what's moving up and down? The weights, the barbells. Okay? His muscles, more specifically the cells in his muscles, are supplying the energy, and they're supplying the force. The barbell or the weight is what's moving up and down, right? All right, let's go to the car. What is supplying the force? What's supplying the action? Landon? What's causing it? The engine. What is receiving the action? Landon? The car or the tires. Okay? All right. Now, let's look a little more specifically at those two. Hopefully, it will make a little more sense here in a minute. Oops, not that. This. Kinetic energy is a form of energy that results from an object's motion. Now, usually we think of motion as in, is it moving? Is it going forward? Is it going backwards? Is it moving fast? Is it moving slow? Nicholas, you with me? But kinetic energy could also be in the form of translation, okay, which is moving from one place to the other. It could be rotation, when an object is spinning. That's an example of kinetic energy. It could even be vibration. That's kinetic energy. Okay? The kinetic is the object doing its job? Is it working? Okay? Potential is a form that results from the object's position or arrangement of parts. It is stored energy that can become kinetic. It includes potential electrical energy, potential chemical energy, and potential nuclear energy. Okay? Does it have the potential to either create electricity? Does it have the potential to create motion? Does it have the potential to create a nuclear explosion? Okay? Does it have the potential to produce a chemical reaction? All of those could be a type of potential energy. Okay? Now, in just a second, we're going to practice identifying which object has the kinetic and which one has the potential. And then it should make a little more sense. Okay? Reagan.
So every object has a potential, or every type of energy that is mechanical has a potential energy that it could be potentially like used as a different source of type of energy, like electrical.
Yes.
So whenever like the roller coaster is going up and down, it's almost like the kinetic energy like charges up and then like
Yes.
fires.
Yes.
So like as it's going up, it's kind of in the middle. But then it reaches the top, and then the potential energy goes up, and the kinetic energy goes down. But then it starts shooting back, and then the kinetic energy.
Exactly. Very good. Landon. Yes. an object supplying the force, and an object receiving the action. All right, let's practice. Which of these is kinetic and which of these is potential? Okay, let's start with this one. The golfer in mid-swing. Is that showing kinetic or potential energy? Caleb? Potential? Is he performing the work? Kinetic.
Also, I didn't get the.
Okay, look off of Layton. Okay, what about this one? Okay, I'll help you both in a minute. This one, at the top of his swing as he's about to come down. Reagan?
I'd say it's probably potential because it's all built up.
Correct. It's all built up. For a second, he's going to actually pause before he converts to kinetic. Does that make sense? So here's the kinetic, here's the potential. Caleb, did you get the notes from Ethan? Okay, which one are you missing? Motion. Because we haven't gotten to it yet. That's why. But we'll get to it in a second.
Actually, it's funny because that was my original second thing before I
Perfect. All right, this one. Which one is kinetic? Which one is potential? Bella? Left and right. So potential and kinetic. Raise your hand if you agree with her. Good, you're correct. Why, Bella?
Well, because the one on the left hasn't already exploded. It still has the chance to do it,
Mm-hmm.
and the one on the right has already.
Very good. Okay. This one is not blown up yet. It's not performing the action, but it could. In fact, it's about to, right? Over here, it is performing the action. Therefore, it's the kinetic. Yes? All right. Let's do another one. Let's do this one. Which one is kinetic? Which one is potential? Nick?
Potential is off, kinetic is when it's on.
Why?
Because when it's off, the potential to turn on. The one that's turned on is doing the action.
Very good. Now, this is where it gets a little confusing because mechanical energy is not just the energy of motion, okay? It's also the energy of performing the action, right? So here, it's not performing the action. The light bulb is off. Therefore, it has the potential to perform the work, but it's not yet, okay? Over here, the light bulb is on. Therefore, it is performing the action and is performing the kinetic energy. Make sense? All right, last one. These cutie little kids. Connor?
The left one is potential because she thought she might jump, but it's a high probability she will. But the kid on the right is jumping like crazy.
So he's the what?
So he's the kinetic.
Very good. Potential over here, kinetic over here. Excellent. Caleb? Yes, it is light energy, but it's also the kinetic part of the mechanical energy. You can have more than one type at a time. Good question. Okay? All right, so simply put, mechanical energy is the energy of motion. We probably should say the energy of action because they're not always moving, but either way, I think you get the idea. Yes.
So, what you were saying, how there's like more energy at one time. The light bulb would actually probably be three light energy, mechanical energy,
And thermal.
oh yeah, and plus it's an LED light bulb.
Essentially. All right. We'll watch the videos later on at the end, but we're going to go on to the next part. Yes. Make it fast.
I really
What?
all the examples you showed us was more like kinetic and potential. I don't think maybe somebody else realized it, but all the potential was worse than
Oh, yeah, that's a problem. I just switched that up. Okay. Next one. Thermal energy. Okay? Thermal energy is what we call energy that comes from the temperature of matter. If you remember back, I think it's at the beginning of the year, we discussed how the root word therm here means heat. Okay? So thermal energy, let me remind you. Your notes are out of order. So flip to the back. Thermal energy is on the back. On your notes, the next one is sound energy, but you got to flip to the back to go to thermal. Sorry about that. Thermal energy, the energy of heat. Energy that comes from the temperature of matter. The higher temperature the matter has, the more energy it has. Okay? Which makes sense. The more energy the object has, the higher the heat, the higher the temperature. Okay? This temperature depends on the movement of the particles inside the substance. Okay? We discussed this with evaporation as well during the water cycle. Okay? As well as changing states of matter. If we have an object that is a solid and all the atoms are kind of stuck together, they're not moving very much, then it will have a lower temperature. But as we add energy to it in the form of heat, the atoms move around a little more and it begins to melt to a liquid. If we can heat them up enough to where the atoms break apart and begin kind of floating around as a gas, then we increase the temperature. Okay? Depends on the movement of the particles inside the substance. I know. I'll get to you in a second. Okay? When thermal energy is transferred to an object, that is called heat. Okay? Now, heat is not the same thing as temperature. Okay? If I'm measuring the temperature of something, I'm not measuring its heat. Okay? Heat is an act of transferring energy. All right? If I'm really, really, really cold and then I hug someone who's really, 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 really warm, they're going to transfer heat to me and hopefully increasing my temperature. Okay? Temperature is how hot or cold something is. If you're measuring the temperature, you're measuring how hot or cold it is. Heat is thermal energy being transferred to another object. Okay? When you feel the heat from the flame or the heat from a fire, you're actually feeling the transfer of energy from those molecules to your hand. Okay? It heats them up. Same thing when you rub your hands together. Okay? If you move them slow, you get a little bit of heat, but not much. But the faster you move, the higher the heat. Okay? So, fun fact, cold is not something you can add to something. Okay? You cannot add cold. If I want to make something colder, I can't add cold. All I can do is take away heat. All right? Even if I have a glass of water and I want to make it colder, if I add ice cubes to it, I'm still not adding cold. The ice cubes take away some of the heat in the water, which makes it colder. It lowers the temperature. Make sense? Anna?
Cold is just the absence of heat.
Correct. Kind of like darkness is the absence of light. Nicholas?
So, would
With the who?
With the boiling,
Boiling. Okay.
would there be potential energy because as the potential boils?
I would say that the stove has potential energy because it has the potential to create the action of causing the heat. Good question, though. Connor?
So whenever you like hug people whenever you're warm, for some reason, I'm just warm when it's always cold outside.
You run pretty hot.
Like I don't even run, and my mom just gives me a hug when we're outside sometimes, and she's like, "How are you so warm?"
Mm-hmm. Some people's body temperature is just naturally a little warmer than others.
Oh my god.
My older brother is like that.
My dad, he's like a radiator for my mom.
I feel
Yeah.
like I'm a heater. For my
That's fair.
That's what my dad says, and then my mom's like, yeah, he's so correct.
Yes, you are. All right, we'll do Parker, Caleb, Sophie. Then we gotta go on. Parker.
I didn't know that if it got hot enough to come over, there were lights on fire, and if it got cold enough to move it, like snowplow.
I know, right?
It's crazy.
Imagine it did.
Caleb.
My brother is the complete opposite. There's like completely freedom.
Excuse me. He raised his hand. Yes, some people, and that also can be, for example, my dad has a very hard time keeping his legs warm. But I think it has to do with the fact that he has not as great. First of all, he's very tall, so he also has a lot of legs to keep warm. But he also has, it's harder to circulate blood through his legs, so he has like less blood vessels or something like that. Either way, his legs get very cold a lot. Go ahead. Yes, your brother is very tall. He's grown quite a bit since he was in 5th grade. Sophie?
I have to keep a lot of things in my room because when my puppy recently, he lays on top of my leg or on top of me, so it gets like really hot and really.
Yep. Lots of thermal energy there. All right. Okay, we're gonna stop there with the notes. I'm gonna show you the couple of videos up there, and then I'll give you your snack. Tomorrow, though, we'll finish with sound energy.